Okay, Chuck, this part here is for your benefit. You see how we had to cut the frame away to compensate where the shaft goes. Basically, the shaft's going to go from the bottom of those cross-member tubes down to the top of the guard we have over the air valves. Your shot of it. So you can see what a real tight space we had to work with here. We're going to simulate the shear operation here, and we're actually going to break the LS1 limit switch. We'll show you how the arms go down. Hit it, Junior. That's what's going to happen when the shear strokes. Then the operator is going to determine for it to come back up. He's going to select, he's going to hit his arms again. The advantage of the push buttons is for some reason the plate should get hung up on the sheet support system. The arms would physically push it off as they come up. You can see it, but we've laid a piece of plexiglass up on top of the arms to simulate a piece of sheet metal. The arms are going to be approximately within an eighth to a quarter of an inch of the table height to ensure that the plate stays level with the table as it's going through the pass line on the cut. Basically, this is what's going to happen is as the plate is through the shear, it's going to be setting like this. The shear is going to stroke, and ideally the piece would slide off. Being a piece of plexiglass, it wouldn't though. Not enough weight, not enough stamina coming down. This particular machine has two 4-inch bore cylinders on each arm, which gives it approximately 2,000 pounds worth of lift power. But the disadvantage to it is the mechanical ability of the arm being longer than the actuator down below. Looking at the back of the shear end, each plate you see is covered with floor plate. It's approximately 12 inches wide. The whole machine is made of tubular steel, 1/4-inch wall, 2x2 tubing. There's approximately 120 feet of tubing built into the frame of this machine. So it's really a rugged little booger for sure. Switches will be mounted to the back gauge off the top of the ram, so the back gauge will physically trip these limit switches. This will allow whatever material support arm to go up that is either hit or missed by the back gauge. As the back gauge goes in, it knocks the arm down, which does not allow the support arm to come up. As it goes backwards, it allows it, when a push button is operated, it allows it to go back up. Everything on the machine works off of an LS1 limit switch, and it runs button boxes mounted to the face of the shear. You have your on-off switch for all the arms, your first row, your second row, and your third row. It's just a matter of pushing the button to bring the arms back up after a cut. Keeping in mind that this is not a production machine. I must stress that point to everybody. Out of the top of that box is the LS1 limit switch that you see up there on the top. That limit switch is operated by the ram movement up and down. And once the ram starts us down, that limit switch would hit a neutral position, dropping the material support arms. The nice thing about this unit is it only takes 110 electrics to operate the machine. For this particular machine, as we usually ship them, we ship them with a little 110 cord on them. 9 times out of 10, the customer rewires it into the panel of the shear off their transformer. 80 psi is all that's required to run this machine, and we ask that you forgive the quality of the tape and the narration, but we think